Hello everyone. I will now give an overview of a software OER, open educational resource, that we have using the FOSSEE project. So I have now opened the software fossee.in. You can see it here, and it says that we promote open source software. Let's scroll down a little bit. You can see some of the projects that it does. So I am going to describe some of the OER available through this project with Scilab.in as an example. So this says that what Scilab is about and so on. So if I click this, so this is the Scilab.in. Let me click this textbook companion project. This is one of the OER, very successful OER that we have created. I would like to describe this. What is textbook companion? Basically, take a standard textbook and code every example, solved example of that textbook using Scilab. It says that if you click here, you will get more details. For example, I have clicked it, you can see what it is, how does one participate and so on. Now let us come here on the left hand side. You have various options like internship, guidelines for coding, honorarium and so on. Now let me go to completed books. If I click this, I will get this page. Then we go to completed books, and it says that we have completed 535 books. This is a very large collection. If there are 100 examples per book, then we have more than 50,000 code available through this effort. You can see that these are organized through various topics. If you scroll down, you will see a lot of options. Now if I click this, for example, automatic control systems, then I will get the next page. Okay, this is what it gives, and it says that who is the author and so on, but on the right hand side it says who created this textbook companion. Now it gives you the option to download the code to use it offline. You can download the PDF so that you can see it as a book. Instead, you can also download, let's say, code for particular chapter or a particular example within that. Let me say body plot. Okay, so then it says that I have an example, I can download these also. But what I have done is I have already downloaded the PDF. Let me show what it looks like. So here is the book that I downloaded, and it says that who created this and so on. And then here it says the list of codes. So let us click one of these, inverse Laplace transform, and it takes you to example 2.8, and if you scroll down, you see that it has code after code after code. Okay, so we are not giving the book, but we are giving code for solved examples of many standard textbooks. So let us go back. Okay, it is also possible for you to download the examples directly, or for only one chapter, or within a chapter one example. This is the Scilab code, and as I told you, we have done it for 535 books. So I have come back to completed books. Let us go to the top, and if you click here, you will see several books in progress. Okay. Now I am going to show one other feature that we have here. We also have this on the cloud. All the examples are available to be executed on cloud. Of course, we have made available Scilab also. The website link is cloud.scilab.in. So here, for example, you can choose anything. Let us say, suppose I select control theory, then it gives several options are available here. Let us take the first one, automatic control systems. Let us take frequency chapter 9, and then it offers several examples. Suppose I take Bode plot, then I can say execute. Of course, in order to do this, you need to be on the cloud. That means internet should be available to you. The previous one in which you downloaded, you can do it offline. Alright, what happens is now this example is sent to the Garuda cloud in Bangalore, where it executes and the result will come. So let us not wait for it. While it is computing, let us go to the next tab, where I am using a very nice feature that we have enabled. See this search button here, and I have TBC code search. I have selected TBC code search and I have searched by a command csim. When I did the search, I get all these different usage. If you do a web search, let us say Google search, and you say that I am going to search by csim, you will get a million hits, but then not many of them could be relevant to you. Whereas here it gives all the relevant things along with the code. Now, for example, the first hit is modern control engineering K Ogata. It says view this example. So if I click this, it asks you, is it okay to go outside? You say okay. Then it opens a new tab and it puts that particular example in the cloud, and of course you can execute this. Let us come back here, let us see whether the previous one is computed yet. Look, it is already computed, the Garuda, the example that I said in BCco. Let me close it. Let me also show you that it is possible to change the values here. Let me change from 2500 to 5000. Okay, you may also want to note the gain margin and phase margin. Those of you who are familiar with the control will know that if I increase the gain, both the margins will come down. So let me execute this. So while executing, let us see whether the other example has been solved. Here it is, the other example that I opened has been solved. Okay. Now what I want to do is I want to take up the next one in scilab.in, which is lab migration project. So basically I clicked this lab migration project in scilab.in and I got all this. What is the lab migration project? So basically it says that if you have a MATLAB based lab and you want to switch over to Scilab code, we would be happy to help you. We would give all the Scilab code required so that you can switch over from MATLAB to Scilab in your lab. So it tells you all about it, and then if you come to the left hand side, it tells you what is the procedure, coding guidelines, how we can give honorarium for you to do this, and completed labs. Let us go to completed labs. You can see the many colleges and many labs that have already completed various things. So let us go to the top. The first one says Tripura Institute of Technology that has done image processing. So let us see what happens. Okay, once again it is the same thing. Download PDF of lab solution, same as what I did before, and then you can download the solution one at a time and so on. Here is the solution provider. So you can say download PDF of lab solutions. If you click this, then it says how do I open. Here is a PDF file. You can actually open this and see what it looks like. Okay. So you can see that they have about 15 different things. So let us go to morphological operations. Here is the example for that. Okay. Let us come back. So that was download code. Now the next one is labs in progress. So let us go back. You can see a large number of labs are already available. I would encourage you to participate in this, offer to port this, migrate your lab, and then your name will come here. Not only that, you will be offering whatever you code to the outside world. So here is an example of a collaborative content creation, lab migration and textbook companion. They are both examples of collaborative content creation. These are extremely useful. More than 1,000 students and faculty members from across the country have participated in this project to build OER. Let me show you the next one, labs in progress. So you can see a large number of labs are in progress. We would encourage you also to participate. Now I want to point out a similar thing is available, namely lab migration and textbook companion are available for Python, for eSIM. eSIM is an electronic design automation software. This also has collection of textbook companions and lab migration. You can use this for circuit design, layout, PCB manufacture and also simulation. OSDAG is for steel design, DWSIM is for chemical process simulation. It is an alternative to Aspen Plus, for example. OpenFOAM is a great alternative to Fluent. This is for computational fluid dynamics. There are various things that are available. For example, here Sandhi we have, it is an alternative to LabVIEW that is being created at IIT Bombay. eSIM is created at IIT Bombay. OSDAG is getting created at IIT Bombay, and of course we are porting several toolboxes. We are raising the levels of Scilab toolboxes to that of MATLAB. So all these software packages are available through this web page, and also the OER created by college students and faculty members on all these great software systems are available. So with that I come to the end of this presentation. I encourage you to go through the web pages. I will give some specific assignments on this topic later on. I would want you to participate in this, benefit by this and also help others. Thank you for watching. This is Kannan Moudgalya from IIT Bombay. Goodbye.